Amid a sea of ancient tiled roofs, several giant steel needles seem determined to pierce straight through history. Bell towers built centuries ago still hold the highest positions on the skylines of many European capitals. Even in wealthy, crowded, expensive centers, buildings several dozen stories tall remain strangely rare. While Manhattan, Shanghai, and Dubai rise as vertical forests, many European squares remain surrounded by low buildings. Engineers here can design deep foundations, steel structures, and modern facades as advanced as anywhere else. By ordinary logic, the more expensive the land and greater the demand, the more a city should build upward. These urban cores should therefore have been gradually replaced by soaring office and apartment blocks. Without protected view corridors, a new project could obscure the dome that once guided the entire city. Without conservation laws, rows of low buildings could be assembled and transformed into vertical development sites. If old infrastructure suddenly absorbed thousands more people, streets and public utilities would face enormous pressure. Yet these cities remain wealthy and crowded without turning their historic centers into forests of skyscrapers. Their density often comes from continuous mid-rise blocks, inner courtyards, and tightly woven street networks. Towers still appear, but they are usually directed toward new financial districts or selected transport hubs. This is urban Europe, where height is not merely an engineering matter, but a decision about memory. The conflict between growth and preservation raises one question: how much of the past will a city sacrifice? Most European urban cores were formed long before elevators, steel frames, and the modern office economy. Cities grew around churches, fortresses, markets, and river ports, with daily life concentrated within walking distance. Streets followed terrain, defensive walls, and old property lines, creating small, irregular, and confined plots. For centuries, exceptional height belonged to bell towers, palaces, or public buildings carrying symbolic authority. Homes were commonly joined in continuous rows, moderately tall yet covering street fronts and enclosing courtyards. This building pattern created substantial density without requiring a single tower to rise far above the neighborhood. When industrialization drew people into cities, new outer belts expanded instead of replacing entire historic centers. Railways, trams, and boulevards allowed cities to spread outward, reducing pressure to concentrate everything in one place. In some places, widespread wartime destruction opened opportunities to rebuild, but reconstruction choices differed greatly. Many cities restored old streets in proportions because they were considered part of collective memory. Others built modern housing districts outside the center, separating new demand from historic squares. Over time, old buildings became more than private property. They became part of the city's shared value. Conservation movements reacted to rapid demolition, encouraging heritage registers and stricter approval procedures. Each roof, facade, and view axis gradually became a page in a history book written in stone. What was protected was not only individual buildings, but also open spaces, street proportions, and their relationships. Planning authority largely rests with cities and nations, so Europe has no single rule governing building height. One city may accept a financial tower cluster, while another preserves its skyline almost completely intact. The question is therefore not whether Europe missed the skyscraper, but which path each city deliberately chose. The first response was not a complete ban, but height controls based on street width, daylight, and safety. Early regulations kept rooflines at similar levels, preserving continuous streets while allowing sunlight to reach sidewalks. When elevators and new structural systems appeared, taller buildings began to challenge the established urban order. The earliest projects revealed that height changed not only one plot, but the skyline of an entire city. Cities began measuring shadows, setbacks, and effects on public squares instead of checking structural strength alone. In heritage districts, new facades often had to match neighboring window rhythms, materials, and proportions. Developers discovered that buying central land did not automatically grant the right to build as high as desired. Development rights became the result of negotiation among profit, public benefit, and historical value. Some cities reserved land outside their historic cores for large offices and modern infrastructure. That distance allowed towers to rise without standing directly behind ancient domes or bell towers. The first clusters often appeared near railway stations, ring roads, or industrial areas that had lost their purpose. Larger plots there provided room for foundations, service areas, emergency access, and plazas around tower bases. Meanwhile, historic centers kept adding density through attic conversions, apartment subdivisions, and better use of courtyards. This became a characteristic adaptation, adding space within old structures before lifting the entire city upward. Public review processes also emerged, giving residents opportunities to question shadows, traffic, and neighborhood identity. This slowed projects, but forced architects to prove benefits extending beyond an impressive appearance. A tower was therefore no longer a private decision by one landowner, but a test for the entire neighborhood. From scattered reactions, Europe gradually formed a deliberate system for managing urban height. The system matured when cities turned aesthetic choices into maps, regulations, and formal review procedures. Heritage boundaries identify places where even minor changes must prove they will not diminish historic value. Conservation registers may protect facades, roofs, staircases, or entire structures depending on their importance. Height limits are set district by district rather than applying one identical number across an entire city. In some places, imaginary planes extending from viewpoints to landmarks must remain permanently unobstructed. London manages several strategic views, so major landmarks can still be recognized from a distance. Even a project outside the historic core may be altered if it appears within a protected backdrop. Shadow models reveal when a building will block sunlight from squares, parks, and homes throughout the day. Skyline simulations test new building forms from numerous streets, bridges, and elevated public viewpoints. Heritage assessments examine not only materials, but also how a project changes the experience of historic space. Transport authorities calculate whether stations, buses, and sidewalks can absorb the additional flow of people. Fire departments assess access, evacuation, water pressure, and operational capacity at great height. Utility providers examine electricity, water, drainage, and telecommunications before a city accepts greater density. Fragmented ownership makes combining many small plots into a viable site both time-consuming and expensive. Below ground, old tunnels, railways, and utilities can make tower foundations exceptionally difficult to design. Investors add design, consultation, and legal risks before deciding whether additional height remains profitable. Planning therefore determines not only how tall a building may be, but where height actually makes sense. Paris separates most of its high-rise skyline from the historic core through outer business districts. Frankfurt accepts planned tower clusters, creating a striking exception within Germany's network of cities. Rotterdam used reconstruction opportunities and Portland to develop a high-rise identity unlike many older cities. These examples show that Europe has no single skyline, but many different urban agreements. The system ultimately works like a filter. Technology creates possibilities, while planning decides which are used. What is easily overlooked is that height is only one method of creating density, not the only one. A continuous row of 6 to 8-story buildings can provide enormous floor area across a broad district. Skyscrapers devote substantial space to elevator cores, staircases, mechanical systems, and load-bearing structures. As buildings rise, more elevators are usually required, so rentable area does not increase evenly with height. The lower floors must also contain lobbies, loading areas, mechanical rooms, and safety setbacks. A mid-rise block filling an urban parcel can therefore use land more efficiently than a tower surrounded by open space. The second mechanism lies underground, where enormous loads must pass through foundations into stable soil layers. Within historic cores, archaeology, old basements, and metro lines may restrict where piles or retaining walls can go. Building deep foundations on narrow streets increases vibration, noise, and risks to neighboring structures. The cost comes not only from concrete and steel, but from protecting the functioning city surrounding the site. Higher above ground, stronger winds demand rigid structures, damping systems, and aerodynamic building forms. At a tower's base, downward winds can make public squares uncomfortable when microclimate design is poor. Shadows stretch farther in winter, when the sun is low, and daylight is especially valuable in northern cities. Large glass facades also increase demands for heat, glare, and energy control throughout a building's life. Elevators, water pumps, and climate systems must move people and energy across dozens of floors. These systems create dependence on specialized maintenance, reliable electricity, and long-term replacement equipment. The third mechanism is transport. One tower concentrates a huge number of journeys at a single address. If a nearby station has sufficient capacity, high density can function without requiring excessive car use. If roads and stations are already overloaded, added height can force crowds into spaces that are already confined. This is why many tower clusters stand at major interchanges where railways and metro lines meet. This is not an escape from the center, but a shift of economic gravity toward infrastructure that can support it. The fourth mechanism lies in land value, but expensive land does not automatically make skyscrapers profitable. Developers compare sale prices with the costs of land, foundations, structures, financing, time, and approval risk. When procedures take years, interest costs and redesign risks can erase profits from additional upper floors. Conversely, clear planning rules within a designated cluster can reduce uncertainty and attract investment. The fifth mechanism is the protected view corridor, a three-dimensional space rather than a line on a map. Each project is tested from designated viewpoints to see whether it intrudes upon the silhouette of a landmark. Even a tower several kilometers away can disrupt the composition if it stands directly behind a dome. Location can therefore matter more than absolute height. Shifting several blocks may completely change the impact. The sixth mechanism is ownership, where dozens of landowners may control small pieces of one urban block. Land assembly must resolve leases, access rights, shared walls, and interests that do not always align. While negotiations continue, a project may miss the market cycle and render its financial plan unworkable. The final mechanism is legitimacy, because the skyline is seen by everyone but owned by no one. Public hearings allow residents, experts, and investors to debate benefits and losses that are difficult to price. Height decisions become political choices about who benefits, who lives in shadow, and who can remain. The stone book is not closed. Each new project is added only when the city accepts how it continues the story. Keeping the skyline low also carries costs that postcard images rarely reveal. When housing supply is restricted near major employment areas, purchase prices and rents can rise sharply. Lower-income residents are pushed farther away, turning distance from the center into a daily cost in time. Preserving a beautiful neighborhood can unintentionally preserve scarcity and the privilege of living there. Subdividing old apartments creates more homes, but they may lack elevators, daylight, or energy efficiency. Overly rigid rules make roof conversions, lightweight additions, and changes of use slow and expensive. A city may preserve its facades yet lose long-term residents as housing becomes an investment asset. Tourism generates revenue, but short-term accommodation can make historic centers feel less like residential neighborhoods. Conversely, building towers does not automatically create affordable housing for most residents. High land, structural, and financing costs often push new developments toward expensive market segments. A luxury tower may add extensive floor space while still failing to provide the housing a city actually lacks. Single-use office towers can also create empty nighttime districts and dependence on economic cycles. When office demand changes, deep floor plates and large cores are not always easily converted into homes. Demolishing old buildings for taller replacements also releases carbon already embodied in existing materials and structures. Retaining a building frame can conserve resources, but reinforcement and technical upgrading remain highly complex. New height brings additional shadows, wind gusts, and infrastructure demands that surrounding communities must share. When developers receive the benefits while neighborhoods absorb the costs, opposition becomes understandable. Consultation protects the public interest, but it can also turn uncertainty into another form of urban cost. Good projects sometimes become trapped alongside bad ones because the system cannot distinguish them quickly enough. Conversely, rushed approval can leave a skyline mistake visible for generations. The greatest hidden cost is forcing a city to choose between two forms of scarcity: space and memory. No choice is free. Building low or high distributes benefits, risks, and access in different ways. The conflict became especially visible when a high-rise project appeared near Vienna's historic center. The new development promised modern functions, major investment, and the image of a city confidently entering the future. Supporters argued that a living city could not be frozen like an open-air museum. Yet from distant viewpoints, the new mass threatened to intrude upon a skyline formed over many centuries. The issue was not whether the building looked beautiful or ugly alone, but where it stood within the wider view. A tower that appears small on a drawing can dominate when it rises behind palace roofs and parkland. The debate quickly expanded beyond one project to how Vienna managed its entire World Heritage area. In 2017, Vienna's historic center was placed on the list of World Heritage Sites in danger over high-rise development. This was not an order to close the city, but a warning that its controls had failed to inspire sufficient confidence. Investors, officials, heritage experts, and residents viewed the same skyline but assigned it different values. For developers, additional height creates floor area and improves the chance of recovering costs on expensive land. For conservation bodies, the open space around domes and bell towers creates irreplaceable value. For residents, a project may bring jobs while also changing shadows and the familiar character of place. Designs were revised, impacts were assessed, and alternative proposals repeatedly returned to the negotiating table. Each reduction in height or change in form revived the same question: how much alteration was enough? The Vienna case showed that heritage is not a motionless object, but a fragile relationship between buildings and context. It also showed how international designation can directly influence planning decisions at city level. A project covering only a few plots forced the system to reconsider building laws, management plans, and responsibility. The crisis offered no simple answer because both development and preservation had legitimate arguments. The extreme problem is that height mistakes become very difficult to correct after thousands of tons of structure rise. Digital models, field viewpoints, and independent reviews therefore become essential before nearly irreversible decisions. Vienna turned confrontation into a lesson. The skyline is cultural infrastructure, not merely unused airspace. After such disputes, many cities made heritage assessment part of the earliest design stages. Planning teams built three-dimensional models to view projects from squares, bridges, parks, and distant elevated points. Architects had to test multiple heights, slenderness ratios, and materials before a final form could gain approval. Some places paused high-rise projects in sensitive areas until clearer management frameworks were established. Permitted high-rise zones were defined more precisely, helping investors understand where development could proceed. Instead of scattering towers randomly, cities grouped them into clusters to manage transport and overall visual impact. Tower bases were required to become more open, with public routes, services, and spaces active throughout the day. Single-use buildings gradually gave way to combinations of offices, housing, hotels, and community facilities. Station area planning concentrated density where people could arrive by train, tram, or on foot. Old industrial districts and railway yards became transition zones between historic cores and modern cities. Within city centers, new solutions often began with reuse rather than complete demolition. Structural frames were retained while interiors changed to meet housing, workplace, and energy standards. Lightweight rooftop floors could add space without greatly changing proportions seen from the street. Courtyards were opened to daylight, ground floors were activated, and vacant uses were converted into new homes. Whole-life carbon assessment shifted the question from building high or low to building new or retaining what exists. Consultation also moved from late-stage opposition toward early dialogue while designs could still change. Cities learned to demand clear public benefits in exchange for height, such as housing or open space. Modern responses do not erase conflict, but turn it into a process shaped by data, conditions, and accountability. The first misconception is that Europe has no skyscrapers. In reality, many cities possess clearly defined high-rise clusters. London, Frankfurt, Warsaw, Milan, and Rotterdam show that high-rise engineering is used wherever planning allows it. The difference is location. Towers usually concentrate outside historic cores or within designated development corridors. The second misconception is that low buildings mean low density, although mid-rise urban blocks can be extremely crowded. Maximum height tells only part of the story. Site coverage, apartment size, and land use determine actual density. The third misconception is that limits only protect tourism, although daylight, transport, and housing also matter. Conversely, heritage is not the only constraint. Foundation costs and profitability also limit projects. The final misconception is that building high always solves housing crises, although housing type and price determine the result. One luxury tower cannot replace thousands of affordable homes distributed near jobs and transport. Europe does not reject height. Many cities simply reject placing it everywhere and at any cost. A low skyline is therefore usually the product of accumulated choices, not a sign of limited capability. The new turning point asks not whether a city should be tall or low, but what density suits each location. High-rise clusters can grow around major stations, while heritage cores add homes through careful adaptation. Digital models allow shadows, wind, and views to be tested before any concrete foundation is poured. Transport data directs added floor area toward networks with remaining capacity, not merely the most expensive land. Old office buildings are considered for conversion, reducing demolition and using infrastructure already in place. Business-only districts are gaining housing, schools, and green spaces to become more active and livable. Lightweight materials and hybrid structures make controlled vertical extensions possible on some existing buildings. Climate planning also requires projects to assess heat, shade, wind, and carbon instead of maximizing floor area alone. Affordable housing is becoming an important condition when cities grant additional development rights to a site. Rail-connected secondary centers can share growth and reduce pressure concentrated on one historic core. The best solution may therefore be not a taller landmark, but a more intelligent distribution of density. Future skylines will combine selected towers, mid-rise blocks, reused buildings, and protected open spaces. Each city is rewriting its architectural constitution under pressure from housing, climate, and memory. At night, lights rise inside new towers while old tiled roofs maintain their low rhythm around the square. Between them lies not the emptiness of backwardness, but a boundary the city has chosen and continues to negotiate. The history book written in stone remains open, but steel needles enter only the pages able to endure them. The final skyline tells a story deeper than height, which memories remain and which future is given space.